There was a moment, 13.8 billion years ago, when there was no space, no time, no matter, no energy, no darkness, no light. There was literally nothing, not even nothing, because nothing implies empty space. And space didn't exist yet. And then, in a fraction of a second, everything that has ever existed, or will ever exist, exploded into being. This is not a myth. This is not a guess. This is the most tested, most confirmed scientific theory in human history. And the real story is far stranger than anything you were taught in school. First, let's kill the biggest myth. About the Big Bang, it was not an explosion in space. There was no space for it to explode into. The Big Bang was not matter flying outward into an empty universe. The Big Bang was space itself expanding. Every point in the universe moving away from every other point simultaneously. Imagine drawing dots on a balloon and blowing it up. The dots aren't moving across. The balloon's surface. The balloon itself is getting bigger. That is what happened to the universe at the very beginning. What scientists call time zero. The entire observable universe. Everything you can see in every direction, with the most powerful telescope ever built, was compressed into a region smaller than a single atom. The temperature was so incomprehensibly hot that the fundamental forces of nature, gravity, electromagnetism, the strong force, the weak force, were all merged into one single, unified force. We do not know what triggered the expansion. We do not know what came before, but we know exactly what happened in the moments after. And it is extraordinary that in the first fraction of a second, we're talking 0.00001 seconds. The universe cooled just enough for the fundamental particles to form. Quarks appeared. Then they combined into protons and neutrons. The building blocks of all matter in the universe formed in less time than it takes you to blink. By the time 1 second had passed, the universe was already 1 billion degrees. Electrons were zipping around freely. The universe was a hot, dense, opaque fog, so thick that light couldn't travel through it. If you were somehow there, you would see nothing. Complete white fog in every direction by 3 minutes. Protons and neutrons began fusing together into the first atomic nuclei, hydrogen, helium, tiny amounts of lithium. These 3 elements are still the most abundant elements in the universe today. 13.8 billion years later, everything else, carbon, oxygen, iron, gold, was made later. Inside stars, the universe was now 3 minutes old, and it would stay as a hot glowing fog for the next 380,000 years. Here is the part that sounds most insane. In the very first moments of the universe, we're talking between 10 to the power of minus 36 seconds and 10 to the power of minus 32 seconds after the Big Bang. The universe expanded faster than the speed of light. This period is called cosmic inflation. And yes, faster than light is allowed here, because it wasn't matter moving through space. Space itself was stretching. Einstein's relativity only limits how fast things move through space, not how fast space itself can expand. In that unimaginably brief moment, the universe went from something smaller than a proton to something roughly the size of a grapefruit. That doesn't sound impressive until you realize the scale of that expansion would be equivalent to something the size of a virus growing to be larger than the observable universe in less than a trillionth of a second. Cosmic inflation explains something that puzzled scientists for decades. Why the universe looks the same in every direction. Why the temperature of space is almost perfectly uniform no matter where you look. Inflation smoothed everything out like stretching a wrinkled sheet for 380,000 years. After the Big Bang, the universe was a hot, glowing fog, too hot for atoms to form. Then something remarkable happened. The universe cooled just enough for electrons to combine with atomic nuclei. Suddenly, atoms formed, and the universe became transparent for the first time. Light could finally travel freely. That moment released a flash of radiation that is still traveling through the universe today. We can detect it with radio telescopes. We call it the cosmic microwave background. It is literally the afterglow of the Big Bang, still visible. 13.8 billion years later, but the universe was now dark. No stars, no galaxies. Just vast clouds of hydrogen and helium drifting through space. Scientists called this the cosmic dark ages. Then gravity took over. Over millions of years, those clouds pulled together, got denser, hotter, until the pressure and temperature at their cores became so extreme that nuclear fusion ignited. Hydrogen atoms fused into helium, releasing enormous amounts of energy. The first stars were born. They were enormous, hundreds of times bigger than our sun. They burned hot and fast and died in massive supernova explosions, scattering heavier elements across the universe. Those elements became the next generation of stars and planets, and eventually us now. How do we actually know any of this? This is the part that separates science from storytelling. First, the expanding universe. In 1929, Edwin Hubble discovered that every galaxy in the universe is moving away from us. The further away it is, the faster it moves. Run that backward, like rewinding a video, and everything converges to a single point. A beginning. Second, the cosmic microwave background. In 1965, two scientists accidentally discovered a faint radio signal coming equally from every direction in space. It matched perfectly what the Big Bang theory predicted, the afterglow of the early universe. It's been mapped in extraordinary detail and confirms the Big Bang with stunning precision. Third, the abundance of elements. The Big Bang predicted exactly how much hydrogen, helium, and lithium the universe should have produced. When astronomers measured the oldest stars, the numbers matched almost perfectly. 3 independent lines of evidence, all pointing to the same conclusion. The Big Bang is not a guess. It is one of the most well-supported theories in all of science, and now the question everyone actually wants answered. What came before the Big Bang? The honest answer is, we don't know. And it's possible that question doesn't even make sense. Here's why. Time itself was created in the Big Bang. Before the Big Bang, there was no time. So asking what happened before the Big Bang is like asking what is south of the South Pole. The question assumes something that doesn't exist. But scientists have proposed several fascinating possibilities. Some physicists think our universe was born from a previous universe that collapsed, a cycle of Big Bangs and Big Crunches repeating forever. Others propose the many worlds theory, that our Big Bang was just one of infinite Big Bangs happening constantly, each creating a separate universe in an endless multiverse. Stephen Hawking proposed that before the Big Bang, time didn't flow forward or backward. It existed as a fourth spatial dimension, meaning there was no singular beginning at all. Just a smooth transition from nothing into something. The way the surface of Earth has no edge. We don't know which of these is true. We may never know. But the fact that we can even ask these questions, that we can peer back 13.8 billion years and understand how everything began, is perhaps the most remarkable thing about the human mind. Nothing became something. A point smaller than an atom became everything you have ever seen or touched or known. In 3 minutes, the first elements formed. In 380,000 years, the universe became transparent. In a few 100 million years, the first stars lit up the darkness. In 13.8 billion years, a species on a small, rocky planet figured out how it all began. That is the story of the universe, and we are still in the middle of it. New video every week on Next time, NASA's most shocking space discoveries of the last decade. Things they found that nobody expected. Hit subscribe, and I'll see you out there.